needing a spotlight. So, hi guys.
Okay, all right. So 5.3. This is inequalities. Inequalities. And we already discussed there's 4 different types. You can have less than symbols, or you can have greater than symbols. We said 8 is bigger than 4. 4 is the same as 4, so I'm going to put one with an equal sign. Negative 2 is bigger than negative 4. Negative 4 is bigger than negative 12. This cupcake is bigger than this one. You don't have to necessarily have these in your notes. This was just an example. You guys already all talked about these, okay? Just for good measure. But it's not going to stay that easy. You guys have done this before. But I'm teaching you something new. And actually, we already did solve these with equal signs. But now we're going to solve them with greater than. They're called inequality signs. So this will seem familiar, but it's also a little different.
I can read that.
It says inequalities. So here's a few examples we're going to start with. On your homework, you do need to graph these, but they're not asking you to graph, listen please, they're not asking you to graph on a coordinate plane, they're asking you to graph on a number line. I'm going to show you what that means. Yeah, maybe you guys have done this. Okay, so we first are going to pretend like this is an equal sign and draw our line down the middle. How do you get x by itself? Add 12. So I would get x is still greater than, what's 8 plus 12? Yep, 8 plus 12? 20. So on my number line here, so that's my answer, but it's not good enough just to leave it like that. We got to graph it, because I want you to see something. Let's just pick a spot on here and call it 20. Jack mentioned already we had open circles or closed circles. Do you think this one's going to be open or closed?
Open.
Why open?
Because it's not connected to the very last part.
Because it's not, it doesn't have that little line underneath it.
That's what I said.
It doesn't have an equal sign. It cannot be equal to 20. So it's kind of like there's a little hole in our data here. And we want all the numbers that are bigger than 20. So here's like 20. I would count 21, 22, and kind of so on this way. This would be 19, 18. Which numbers are bigger than 20? To the right or the left? To the right. That's how I graph them. Some people like to like shade underneath it. That's fine if you like to. I don't really care. What's another trick that you can use? This only works when the variable is on the left, so you got to be careful. Is I can like lightly draw, make this into an arrow sign. See how this arrow matches this arrow? That's a little trick, so that you know that they're pointing in the same direction. Only works if your x is on the left side. It doesn't work when it's on the right. So solve and graph. So far, not too bad, right? Okay, good. Let's try this one. 4x is less than or equal to 16. My first step is to pretend like it's an equal sign. Divide. This is 4 times x. We'll divide both sides by 4 to get x by itself. So x is still less than or equal to, what's 16 divided by 4? 4. So we could circle that, but then we got to graph it. Let's pick a spot on here that's 4. This time is my dot opened or closed? Closed.
Does it include 4?
It does include 4. So we're including 4 in our solution set. And I want to shade all the numbers that are less than 4. So what numbers am I going to go to the left or to the right?
Follow the arrow.
The numbers that are less than 4 are this way. This is 4, 3, 2, 1, 0, 5, 6, 7, 8, 9. No. Nope. And again, you could pretend like this is just an arrow. So we're shading to the left, shading to the left. Do you have to shade underneath it? No, I don't care. I don't usually. So let's talk about what this means just for a second. When it was an equal sign, if I just had 4x equals 16 and divide both sides by 4, then x equaled 4. How many solutions did I have to this sentence? One, just one solution. But this one, how many solutions do I have? Infinitely many solutions. Because there's infinitely many numbers that are less than 4. Yeah.
So is it the same with the other one?
Is it the same as this? Same idea, but the equals just means you have one answer. It's like x equals 4. That's the only thing that can make this true. But there's lots of numbers that can make this true. Give me a number less than 4.
2.99.
2.998. 2. No more numbers less than 4. 0, -8, -1,000,000. You know what I mean? There's lots of things that make this true. Okay. Now here's for the very, very important thing. It's next to the important box. I'm about to show you something very important. So far everything's been fine. But you have to watch out for one thing when you do these. How do you get x by itself? Divide by -4. And something in your brain should be like, whoa, 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 this means something important. When you divide by a negative, you have to do something. This is the only thing you have to watch out for. You have to flip the sign. So important. When you multiply or divide by a negative number, you must flip the inequality sign. So I like to do that step first. So instead of having a less than like this, I'm going to flip it so that I have a greater than like this. And it's so important, I'm even going to highlight it so you can see the difference here. And it's because we are dividing by a -4 right there, which means that we need to flip our sign right here. So the 4 divided by -4 cancels out, so I just have x on this side. Now x is greater than, what's 16 divided by -4?
-4.
And then that's it for that one. So it's x is greater than -4. So let's put a -4 on here. Open or close circle.
Open.
And then which way am I shading?
With the arrows.
What do you mean with the arrow?
Well, this paint always is the thing with, yeah.
So I'm going to shade. This is pointing to the right, so I'm going to draw an arrow that looks like that. Question, Kaylee?
Yeah, I forgot.
Okay. It's okay. If you remember, I'll try to catch you before you forget. Okay, let's try some more. You guys are doing great. Let's try this one. We got x on both sides now. What do we do with that? We gotta get the x's on the same side. Do you want to move this 1x or the 3x?
1x.
Yeah, I'd move the 1x too. So we could subtract x on both sides. So I can bring my 4 down. 4 is greater than, what's 3x minus x? 2x. Okay, now how do I get x by itself? Divide by 2. Do I need to switch my sign? No, because I divided by a positive. That's okay. So 4 divided by 2 is 2. And then I have an x over here. Is my variable on the left?
No, but can't you just switch it?
Yes.
And
So I'm going to switch it. I'm going to rewrite it. Because it doesn't have to be. I would accept this. The problem is that you're going to graph it wrong if you leave it like that. Okay? So we're going to, so variable needs to be on left side always. So we can flip everything. Which means instead of writing a 2 first, I'm going to write it backwards. I'll write x.
it's less than or equal to 2.
Yep, I'll switch the sign, flip it, and then have a 2. These two things are equal. They mean the same thing. You're just reading them differently. This one I would read it as 2 is greater than or equal to x. This one I'm saying x is less than or equal to 2. They mean the same thing. They're just written differently. This way guarantees you won't make any mistakes. So here's a 2. Open or close circle? Closed. And then which way am I shading? Turn this into an arrow. I need an arrow that's going to point that way. So I'm going to point to the left. X is less than 2. And I'm throwing a bunch of things at you. Questions so far? You guys feeling okay?
Yeah, it's fine.
Okay. I'm glad a lot of this is refreshing your memories. Let's try another example. How do you get d by itself? Minus 13. That's what I would have done first too. When I bring this down, what should I not forget? Negative. Negative 11d is greater than or equal to 79 minus 13. Thank you. How do you get d by itself? Divide by negative 11. So d, Dan's got it. You flip it. Why do we flip it? Switch it. But that's different. That's a different set of. That only happens on the one lesson, one day. It's a special thing. So we do need to flip it because we divided by a negative, which means we need to switch the sign. So divide by negative. So we switch. I could say switch it. Switch it!
Sorry about that.
Yeah, what the heck?
Negative 6, is that right? So that's my answer. We'll graph it. Here's a negative 6. Closed circle. Which way am I shading? Going to shade in this direction. Picture your little arrow here. Okay, 2 more. I'd have you try these on your own, but they're tricky fraction ones. I want to make sure we do these together. Line down the inequality. What do I do first? Minus 14. I like it. So I'll bring this down, and I'll have 3/4 x is less than 11 minus 14. -3. How do you get x by itself? Multiply by the reciprocal. Someone said it. So multiply by, what's the reciprocal? 4/3. So this turns into x is, do I need to switch it?
No.
But this one's negative. Would you switch it?
But x is 5.
The only time you switch it is when, like my blue color here, the number you're multiplying by is positive. That's the only time you switch it. It is going to be -4. Good job. X is less than -4. Here's a -4. Open or closed? Open. And which way are you shading? To the left. So far, so good? You'll have some on your homework that look like this and probably some on your test? Yeah, question?
It's kind of a confusing question.
Okay.
But what if you have, so you have a negative number and you have to switch the...
Inequality? Yep.
Yeah. And then you have the variable on the wrong side. So would it just say...
Then you would switch it back again.
So then it just...
So it end up being original. Yeah. Yep, good question. That happens sometimes. Okay, we're going to get x by itself this time. What's the first step? I still sometimes see these done incorrectly, so that's why I wanted to review this together.
No, you have to do the -2/2 and negative.
Oh, okay, Ari, that is a way you could do it. I'm not going to show it that way, but you could do it that way. That was a good thought. But I'm not going to do it that way. This way, though, we would multiply both sides by 2. Sometimes I still see you guys want to add the 4, which it makes sense. I know why you want to do that, because you want to get that constant out of the way. But we need to cancel out the denominator before you can do anything on the numerator. So we'll multiply both sides by 2. That leaves me with -2x minus 4 is greater than
24 and then plus 4.
24. Oh, that's how you got 28. Yep.
So I know how to multiply already.
How do you get x by itself? Ooh, well, I gotta add 4 first, I guess. I wasn't catching myself up with what Kaylee said. I know, you guys move too fast for me. Alright, so I'll catch myself up here. 24 plus 4 is 28. Now, how do we get x by itself? Divide by -2, and good. Switch it. That was just for you. So we're dividing by a negative. So that's going to switch it. I always switch it first. And then we would end up with x is less than, yeah, what is that, -14? So here's -14. Open or closed? Open. Shade left or right? Left. Good. Okay, thumbs up, sideways down. How confident do you feel about this? You can be honest. Okay, appreciate the honesty. Thank you very much. That's the first half. Yeah, good. I'm glad you feel. I need a Staples "that was easy" button so we could push it. That was easy.
My mom has a button for that.
Does it talk?
Yeah.
I need one of those.
My mom is a
I
teacher.
feel like
That was easy. So like when
Yeah,
kids are
I know, it's
being,
true.
like,
It's more from my
practicing
younger days.
They finally get it. She was,
That was easy button. Okay, this time, remember back in the day on the first day of school, this was the first lesson I ever taught you. On the first day of school, maybe it was the second day of school, when we did 2.1, And, you're all nervous because you don't know where my room is, and it's the first day of high school, and I'm throwing some words at you, and all we have to do is translate equations from words into sentences. Remember that?
Yeah.
No.
Okay, well, I'm refreshing your memory now. And so they're going to give you words. We're going to translate them with inequalities now. I'm teaching you some new words. So some of them are really going to be fine, like 4 times a number. How would you write 4 times a number? Okay, good. 4x. And then it says plus 12. Okay, that's pretty easy, so I'd write plus 12. And then it says is greater than. Okay, so which way is my inequality going to face? Greater than looks like this. So this is my tip and trick box. Tips and tricks. These are all the words I'm about to show you what they mean. If it says greater than, it's going to look like this. Big mouth opening, like greater than is like has teeth. Lots of teeth pointing to the bigger thing.
Let's see a flower.
Yeah, that was kind of a bad drawing. So it's greater than the number minus 3. What does that mean? Good. X minus 3. The number minus 3. So we wrote it, but now we got to solve it. I didn't give myself enough space. How do you solve this? Subtract x. I'm going to need to give myself some more room. So it'd be 3x plus 12 is greater than negative 3. Subtract 12 on both sides. 3x is greater than negative 3 minus 12. Negative 15. How do you get x by itself? Divide by 3. So I'd get x is greater than negative 5. Do you have to graph this one? No. You just have to. So what I'm looking for on your homework is that you wrote it originally and that you solved it. It's write and solve. Write and solve. Let's finish filling out our tips and tricks box so you guys have a second to write that down. If I were you, I would write them all. So I did greater than. What would greater than or equal to look like? Same thing with the line under it. Less than is flipped. Less than or equal to has a line under it. Those should be review. You guys are pretty much familiar with those. But then you have these words. At least, at most, and no more than.
Wait, aren't they?
These confuse me every time. I always have to think about it.
Aren't they the same thing as greater than?
These don't mean the same things as each other.
No.
So at least, here's the example I always use for at least. You have to be at least, at least 18 to vote. Or at least 16 to drive. Or at least whatever. That means your age needs to be greater than or less than 18. Greater than, so that's when I need to know, I need to put a greater than. Can you be equal to?
Yeah.
Yes. So that is a greater than or equal to. At least 18 to vote. Yes. So if your mom says you can have at most 2 cookies,
Why didn't you say 10? Maybe feel good inside.
then how many cookies can you have?
2.
2 or less, depending on your depending on your parent. So at most 2 cookies. That's the example I always use. So that means you can have 2 cookies or less, which means everybody's going to have 2 cookies, right? Yeah, it's cookies. Yeah, I didn't write it very good, sorry.
It's okay. I have what is no more than 15?
And no more than is the same as at most. You can have no more than 2 cookies. Does that mean you can have 2 cookies? Yeah, you can. No more than?
It's the same thing.
Yeah, they're the same thing. It's just 2 different ways to
You
say.
can have more cookies, you just can't like round them.
Yes, that's true. Exactly. This is when all the secrets come out. I should just tell all your parents. Okay, well, they've been sneaking cookies.
I'm a pro that makes the cookies.
Can I have at least 2 cookies?
All right, 2/3 of a number.
You should bring us cookies. And then
2/3 of a number.
how do you give your personality?
It's a small class. It's a small class. 2/3 of a number, that's 2/3 x, is at least, so which one am I going to write? Greater than or equal to, is at least 11. So we wrote it, but then we got to solve it. So how do I get x by itself? Good, I heard it. Multiply by the reciprocal. So I have x is greater than or equal to 11 times 3 divided by 2. It's going to be 33 halves. That can't be reduced, so that's good enough right there. Can you have a fraction? Sure can. This is an instance where decimals are not appropriate for these problems, because especially if they're rounded. This one would be okay because it's a 0.5, so that's an exact decimal. But if it's like a 0.333333333, you can't round. Got to leave it as a fraction. You guys are pretty good with that. Okay, you guys okay so far? Okay, 1/10 of a number is at most -6 minus 8. Just break it up. 1/10 of a number. How do you write that? 1/10 x is at most. What is at most? Is it a less than or a greater than? Less than or equal to? -6 minus 8. So we could solve this, right? I'd have 1/10 x is less than or equal to, what's -6 minus 8? I think -14. I could be wrong. -14. How do you get x by itself?
Times 1 or 10.
Yeah, multiply by 10 over 1, or just 10. So we get x is less than or equal to -140. Done. So you have to write and solve. Four-fifths of a number. I'm just practicing the fraction, so we really got it. 4/5 x is no more than, well, what's that one? No more than would be less than or equal to. The same number times 4. How do I write that? 4x. The same number is the number x that I used, so it'd be 4x. How do you get x by itself this one, on this one? Multiply by 5/4. Oh, shoot. That's not going to work. Well, we can keep going with it. X is less than or equal to, this is going to be 5x. It didn't help me. That was kind of a bad teacher move. Sorry, guys. That's all right. It got rid of our fraction at least. How do I get the x's on the same side? Minus x? What's x minus x? 0 is less than or equal to 5 minus 1 is 4x. How do I get x by itself? Divide by 4. Type it in. 0 divided by 4 is 0. It's 4 divided by 0. That doesn't work. 0 is less than or equal to x, but then how do I... That's not how I want to leave it. I want my variable on the left, so what should I do? Yep. Whew, that was a fun one. Thank you. Caitlin has a budget of $65 for slushies. The school store charges $25 to activate an account. Good thing our school store doesn't do that. And they charge 50 cents per slushie. How much are our slushies? $1? Wow. How many slushies can Caitlin get and stay within her budget? So Caitlin has a budget of $65 for slushies. The school store, so we got a problem solve here. Charges $25 to activate an account. Plus they charge another 50 cents per slushie.
So, isn't it like she has $40 left?
So she can spend $25 plus 0.5, and then we'll call X the number of slushies she's going to buy. So this side is what Caitlin spends. Whoops, sorry, I flipped it. Wagner. Yes. Yes. Yep, bye-bye. So, this is what she spends. How much money does she have to spend? What's her budget? $65 is amount of money she has. So what inequality do I write in between this? What symbol am I looking for here? Yeah, I'm looking for a less than or equal to. Whatever she spends has to be less than or equal to. She can spend all her money. Less than or equal to the 65. So let's solve this out. 25 plus 0.5x is less than or equal to 65. What do I do first? So what do you do first to get x by itself? Minus 25, thank you. That's how much it costs to activate the account. So I'd have 0.5x is less than or equal to 65 minus 25. 40. How do you get x by itself? Divide by 0.5. So x is less than or equal to, that turns it into 80. So how many slushies can she buy? 80 if she spent all her money. So you would write something like she can buy 80 slushies.
Hey, how did you call it? What? Right. Yeah.
You could say she could buy at most 80 slushies if you really wanted to be fancy.
I just multiplied it by 2.
Yeah, same thing. It's, yeah. Okay, guys, you're doing great. 3 examples and we're done. I have to show you, these are the special ones. I don't even know if we're going to do all three of these. These are like the bonus challenge problems. Yeah. 3 and then we're done. Can you make it for 3 more? I know. We're already ready to be done. You guys are doing great. 6C plus. What do we do to solve this out? Distribute. So what's 3 times 2? 6. 3 times negative C? Negative 3C is greater than or equal to negative 2C. We've got a lot of C's going on here. Just like if we pretended like this was an equal sign, how could I simplify this side over here? Combine like terms. 6C minus 3C. What does that turn into? 3C. 3C plus 6 is greater than or equal to negative 2C. Then what? Minus 3C. You could do it the other way too. I would have done it that way. It would take an extra step. This takes an extra step though too. Minus 5C. How do you get C by itself? This is what Kirsten asked about earlier. Divide by negative 5. So 6 over negative 5. I'm dividing by a negative, so what do? Switch it. Switch it. But then it's on the right side. I want it on the left side, right? So I'm going to switch it back again. So C is greater than or equal to is a double switch. That happens. It does want you to graph it. Literally, guys, when you graph these on your homework, put a point on there, call it negative 6/5, close circle, and then I'm shading this direction. That's all I'm looking for. Yeah. Yep, quickly. Okay, 1 down, 2 more to go. Let's solve this out. What do I do first? Distribute. Negative 7K minus 28 plus 11K is greater than or equal to 8K. Distribute the negative. Negative 4K minus 2. You guys don't have to write down. If you didn't print the notes, you don't have to write this. Mostly I would just watch to make sure that you know how to do this. I think you do. I'm just trying to model how to solve a big problem like this. Negative 7K plus 11K. Combine like terms. So that would be 4K minus 28 is greater than or equal to 8K minus 4K. 4K minus 2. We could subtract 4K on both sides. So then I have negative 28 is greater than or equal to negative 2. Oh, let's think about this for a second. Is negative 28 bigger than negative 2? No. It's more negative. I know, the negatives are funky. So, when this happens, this is not a true statement. So what do we say this is? No solution, and to graph it, you just give me an empty number line with nothing on there. There is no number that will make this situation true. Second one down, 1 more to go, then we're done. Let's distribute this. 2 times 4R 8r. 2 times 3 is 6. Less than or equal to 22 plus, let's distribute again, 8r times 8 times negative 2, negative 16. 8r plus 6 is less than or equal to, what's 22 minus 16? 6. 8r plus 6. I think you see where this is going. Minus 8r. Minus 8r. 6 is less than or equal to 6. Is that true? Yeah. This is a true statement. That means, what's my solution set? All real numbers. That means when you graph it, you're literally graphing a number line on top of a number line. You're saying that all of the values are possible solutions. So like, all of these numbers are solutions. Every single number will make this situation work. Cool stuff, huh? We just learned some inequalities. Here's your homework problems. Got lots of time to get it rolling.